Hello, everyone. This is Dr. Abidemi, and today we are going to take a look at the theory of production. So far, we've done the theory of consumer behavior, which takes a look at the demand side of the market. And now we're going to focus on the supply side, which will make us talk about the theory of production. Production is concerned with the supply side of the market. Production is an activity of transforming inputs into outputs. Inputs are resources used in the production process. These inputs entail land, labor, capital, raw materials, entrepreneurship, technology, time. An output is any good or service that comes out of the production process. All right. So let's move ahead. The rate at which a given quantity of inputs can be transformed into output is governed by what we call the laws of production. The laws of production are called the laws of returns or the theory of production. We have the short-run laws of production and long-run laws of production. The short-run laws are called the laws of variable proportion, while the long-run laws are referred to as the laws of returns to scale. Now, let's focus on the short-run laws. First of all, what does the short run mean? When we say short run, what does it mean? And now we are going to further talk about the short run laws of production or laws of variable proportion. A short run refers to a period of time during which supply and the use of certain inputs such as plants, buildings, and machineries is fixed, while some will vary, labor. All right, so in the short run, we usually say you have a fixed factor and a variable factor. The fixed factor is capital and the variable factor is labor. Okay, so in the short run, capital is fixed while labor varies. Okay, here it says that the supply of labor is a variable while that of capital is fixed. All right, so the law of variable proportion, also known as the law of diminishing returns. All right, what did we call this? Is kind of similar when we did the theory of consumer behavior. Okay, when we talked about the law of diminishing marginal utility. All right, in production, it is the law of diminishing returns because we are dealing with different factors or resources, or sometimes we call them the factors of production. Okay, so the law of variable proportion, also known as the law of diminishing returns, is an economic principle that states that as more units of a variable input are added, the additional output produced per unit of the variable input will eventually decrease. Okay, so diminishing marginal returns arise from the fact that more and more workers are using the same capital, okay, and working in the same space. As more workers are added, there is less and less for the additional worker to do that is productive. All right, so the law of diminishing marginal returns is an economic principle that states that as more units of a variable input are added, the additional output produced per unit of variable will eventually decrease. That means, for example, when we take a look at the graph, as total product becomes negative, marginal product will, as total product declines, marginal product will be negative. All right, so we're going to see that when we look at total product of labor, marginal product of labor, average product of labor. All right, so let's move ahead. So for the short run laws of production, one thing is clear: you have a fixed factor and a variable factor, or we say capital is fixed while labor varies. That's in the short run. What about long run laws of production, which is also called laws of returns to scale? In the long run, all inputs are variables. It is a period when a firm can change its plans. All right, so in the long run, all inputs are variables. You can change your plants, or you can change your equipment, or you can change your machineries, or you can expand your buildings. So laws of returns to scale show how the output will respond as capital and labor which are inputs, change. When a firm increases all its input proportionately, there are three possibilities. So in the long run, all inputs are variables. You can change them, right? But when a firm increases all its input proportionately, there are three possibilities. Okay, so we can have constant returns to scale. For constant returns to scale, an increase in total output is proportional to an increase in input. That is, if inputs are doubled, the output is doubled also. For increasing returns to scale, an increase in total output is greater than a proportional increase in input. What does that mean? That means that output is greater than input. What about decreasing returns to scale? For decreasing returns to scale, an increase in total output is less than the proportional increase in input. That means output is less than input. Okay, so these are the three possibilities, and that's why we call it laws of returns to scale. Okay, these are the three possibilities that you have. All right, constant returns to scale, proportional. All right, both input and output grow or increase at the same proportion. Increasing returns to scale, all right, the output increases more than the input, all right, or it's more than the amount of raw materials, or more than your input that you use. Okay, for decreasing returns to scale, the input is more than the output, right? Meaning that you put some certain input, all right, you have the output you get is lesser than the amount of input that you put in or that you expected. So let's take a look at production function. All right, of course, you know, when we say function, we are talking about mathematical or quantitative relationship between maybe two variables, two or more variables. But production function here talks about mathematical or functional or quantitative relationship between input and output. Of course, we've talked about those input and output. Okay, those inputs here you can see output as a function of capital and labor. Okay, we are simplifying the model. This is like a model to just include capital and labor. So here it says output is a function of capital and labor, right? You can see it here. So Q is output, which is a dependent variable. F is a function. K is capital, which is an independent variable or regressors. And L is labor, which is an independent variable or also regressors. All right. So to increase output in the short run, a firm must increase the quantity of labor. You remember that in the short run, capital is fixed. So what you can only toy or play with to increase your output is to actually maybe employ more labor. So we describe this relationship between output and the quantity of labor employed by using three related concepts. One, total product. For total product is the maximum output that a given quantity of labor can produce. Okay? Marginal products. So the word marginal means additional. So marginal product, the marginal product of labor is the increase in total product that results from a 1 unit increase in the quantity of labor employed, with all other inputs remaining the same. So you can see the formula is changes in total product divided by changes in labor. When this total product could be output, okay, which will be Q, you know. 3, average product. The average product of labor is equal to the total product divided by the quantity of labor employed, all right? So average product of labor is total product divided by labor. And you can see it here. If you work this out, when the number of workers is 1, your total product is 24. Your marginal product, you could put dash here, you could put 24, okay, because you don't have anything above it. There are no changes for marginal, okay? But when the number of workers increases to 2 and your total product is 72, what is your marginal product? So what you need to do is 72 minus 72 minus 24 divided by 2 minus 1. Okay, 72 minus 24 divided by 2 minus 1. So you're going to have 48. When the number of workers increases to 3, you're going to have 138 minus 72 divided by 3 minus 2. Okay, for your average product, of course, you know, is total product divided by labor. So 24 divided by 1, 24. 72 divided by 2, 36. 138 divided by 3, 46. Okay, you continue to do that. All right, so if you see as number of workers increase, you could see, for example, when number of workers increase to 11, your marginal product becomes negative. And you could also see here that your total product also begins to decline. So when your total product begins to decline, your marginal product becomes negative. Your average product will continue to be positive, by the way. Okay, so average product remains positive, but when your total product begins to fall, your marginal product becomes negative. Okay, let's take a look at the graph here to explain it. This is it. This is what I explained on this table. For example, take a look at this graph. Initially, your total product is increasing at a diminishing rate. When total product increases, marginal product is also increasing, and average product is also increasing. But you could see that initially, marginal product is greater than average product. You could see this red here. Initially, you could see marginal product is greater than total average product. The average product is the blue line, the marginal product is the red line, and the total product is the black line. You could see that total product is increasing at a diminishing rate. Sorry, excuse me. When total product gets to the maximum, here you could see marginal product becomes 0. You could see that. All right. When total product begins to fall, marginal product becomes negative. But you could see that the average product remains positive. Also, you could see that when MP and AP intersect, for example, AP begins to rise faster than NP. AP, average product, begins to rise faster than MP. Okay, that's what I explained here in this table right here. Okay, so in figure 7.1 below, TP is initially increasing at a decreasing rate. In addition, marginal product and average product also increase and then decrease due to the operational law of diminishing marginal returns. When TP is at maximum, MP is equal to 0. Also, when MP becomes less than AP, AP starts to fall. After that, both AP and MP fall, but MP becomes negative and MP remains positive, all right? Just like I explained. Initially, when TP is increasing at a diminishing rate, MP is greater than AP initially, all right? And later, when the intersection occurs between MP and AP, after that, AP is greater than MP. When TP is at maximum, MP is 0. When TP falls, MP becomes negative. However, average product remains positive, okay? So let's move ahead. Now, we go to the concept of ISOQUANT and ISOCOST, just like when we talked about the theory of consumer behavior when we did indifference curve and budget line. So we also have that of production, the theory of production. Okay. So in the theory of production, our ISOQUANT is our indifference curve. Our ISOQUANT is our indifference curve. It was derived from the Greek word iso, meaning equal, and the Greek word quantus, meaning quantity. The ISOQUANT curve is known as equal product curve and production indifference curve. An ISOQUANT curve is a locus of point representing the various combination of two inputs, capital and labor, yielding the same output. So an isoquant is a combination of two inputs, all right, capital and labor, yielding the same level of output. Just like we did that in the theory of consumer behavior when we did indifference curve, which we said that combination of two goods that give the same level of give the same level of satisfaction. Remember in the indifference curve, we mentioned that whether you consume more of one, less of another, it doesn't matter. It gives you the same level of satisfaction. It also applies in the theory of production in terms of isoquant. In the isoquant, whether you use more of capital or you use more of labor, it will give you the same level of output. For example, if you are using K3 in terms of capital and you are using L3 right here, this shows, for example, more of capital and less of labor here. It will give you the same level of output. If capital falls from K3 to K2, meaning they are using less of capital and more of labor, it will still give you the same level of satisfaction. If it drops from K2 to K1 and you increase your labor from L2 to L1, it will still give you the same level of output. Yeah? So remember that in our indifference curve also, we said the slope of the indifference curve measures the marginal rate of substitution, right? For our isoquant or for our production, the slope of the isoquant curves gives you the marginal rate of technical substitution. The marginal rate of technical substitution. What is the marginal rate of technical substitution? Is the rate at which you substitute one input for another, all right? We will see that right here. Okay? So the rate at which one input or factor can be substituted for another of technical substitution. This means the slope of the isoquant is the MRTS. So the slope of the isoquant curve, this slope right here, this slope right here, this one right here, is the marginal rate of technical substitution. The marginal rate of technical substitution. Okay? So the rate at which one input or factor is substituted for another is called the marginal rate of technical substitution. This means the slope of the isoquant is the MRTS. This concept is significant in production analysis. An isoquant map, therefore, is the combination of more than one isoquant curve. Okay, so if you are going to draw an isoquant map, then it means you're going to have this. You're going to have more than one isoquant curve. An isoquant map, this is it. Okay. All right. So let's move on. So what are the characteristics or properties of this? Should be isoquant. Okay, this should be isoquant curves. So although the characteristics are the same, okay, isoquants have a negative slope. Isoquants are convex to the origin. Isoquant curves cannot intersect one another. Higher isoquant curves denote higher level of output. Okay, let's move to Isocost, which we also call the budget line in the theory of consumer behavior. So the Isocost line shows the different combination of factor inputs that can be purchased with a given budget. Although similar to the budget constraint in consumer theory, the use of the Isocost line pertains to cost minimization in production as opposed to utility maximization. All right, so of course, you know, for theory of consumer behavior, we are taking a look at how individuals are satisfied. Okay, we are taking a look at utility maximization. Okay, but for production, we usually take a look at profit maximization. We also take a look at cost minimization. Okay, profit maximization and cost minimization. Okay, so take a look at the Isocost. So for the Isocost, you can see the Isocost line, capital, labor. Anything outside that red line, you cannot afford it. Anything in that red line, that's what you can afford. So for Isocost, I talked about point of cost minimization or cost minimization. So the point of cost minimization in the theory of production is the point where isoquant is tangent to the Isocost line. Okay, where the isoquant is tangent to the Isocost line, and you can see isoquant, you can see Isocost, you can see the point of intersection right here. That point is called point of cost minimization. The point of cost minimization. Okay, so what are some of the review questions? What is production? What is the difference between short run and long run? What are those time frames? All right. In the short run, you have fixed factor and variable factor. In the long run, all factors varies. You can change your plants, your equipment, you can expand your building. Explain the short run laws of production and long run laws of production. Okay. Short run laws are called laws of variable proportion. Long run laws are called laws of returns to scale. In the long run, you have constant, you have increasing, you have decreasing returns to scale. Then explain the concept of isoquant and isocost. All right. All right. Okay. So I hope that this is clear. This is just a simplified version of the theory of production. Those basic concepts you need to know: what is production, input, output, production function, short run, long run, short run laws of production, which is also called laws of variable proportion, long run laws of production, which is also called laws of returns to scale. We talked about isoquant, we talked about isocost, we talked about point of cost minimization. All right. So I'm going to see you in my next class where we talk about firms and their motivations. Firms and their motivations. Okay. In the meantime, don't forget, if you have questions, you could ask them in the comment section. Then I'll be willing to answer you. All right. In the meantime, till we see again, have a wonderful and a great day. Bye.